colloids, or colloidal dispersions. A colloid is a mixture in which the thing that is dissolved is actually much larger particles than you would find in a solution. They're small enough to stay suspended, but larger than typical solute particles. Typically diameters of 1 nanometer to about 1,000 nanometers in diameter. This is different than a suspension, which can settle out because it has even larger particles. A colloidal dispersion will not settle out. If you've ever made chocolate milk, you know that or had hot cocoa, you know if you let it sit, all the chocolatey goodness part settles to the bottom. The particles are just too large to stay suspended for too long. But a colloid will not settle out. If we look at those particles under a microscope, and they are large enough to see under a good microscope, they have a very distinctive jittery motion called Brownian motion. So, you know, if you were to watch them, they make this jittery motion, and it's relatively random, but it's in little herky-jerky movements. And that's caused by collisions with molecules in the liquid. So they move, they bump into something, they move again, and that's why it's jerky. When you add enough soap to water, the soap will form micelles that are large enough to scatter light. And this is one of the characteristics of a dispersion, is that it scatters light. So here's a soap molecule. Sodium stearate is one thing that functions as soap. It's got an ionic head, so a charged end, and then it has this long nonpolar tail. The long nonpolar tail is not going to be very friendly with the water, and so they'll form little spheres with the polar heads facing out and the nonpolar tails facing in. And soap helps to get grease and oils away because the grease and oil can dissolve in this nonpolar center part and get washed away. The individual micelles are not going to clump together or aggregate because they have negatively charged outer layers, and so they're going to actually repel each other, and they'll suspend themselves in the water. So soap forms colloids. Large molecules are called macromolecules, such as proteins, also form colloids. Here's some examples of colloidal dispersions. Aerosols, where we're dispersing a liquid in a gas. Fog is an example of this. You can have solid aerosols, where a solid is dispersed in a gas. Smoke. Foam is a gas dispersed in a liquid. Whipped cream is a foam. That would be really good on pie. An emulsion is two liquids. So we know that fat does not dissolve in water, right? But if you get processed milk, it's been homogenized. It's been treated so that the fat in the milk forms an emulsion and doesn't just rise to the top all the time, but it stays suspended. A solid emulsion is going to be a liquid dispersed in a solid. Opals are actually water that is dispersed within silica glass. One way you can tell the difference between a colloidal suspension and a true solution is by passing light through it. So here we have a beam of light passing through two glasses of liquid. We can see the light in the first liquid. We see the light because this is actually a colloidal dispersion, and the particles are large enough to interact with the light and scatter it, and so we can see it. Passing through this second solution, we can't see the beam of light because the particles are too small to scatter the light. We see this effect when sunshine streams through the window and there are dust particles in the air. Normally you can't see sunbeams, right? But sometimes you can. My house is especially dusty these days, and so the sun comes in and you see, oh, look, there's a sunbeam showing me all the dust. The dust is scattering the light. Or you'll sometimes see the sunbeams in the sky where there's moisture in the air, and the moisture suspended as a colloid in the air will scatter the light.